Hey guys, unfortunately Margaret's sick, so I'm not going to be in today. I just wanted to show you what page you should have out in your notes. So hopefully you've completed the simplifying imaginary numbers. It was listed as a classwork that was due for today. So hopefully that's been completed. If you didn't complete that yet, I would suggest reviewing these notes that you should already have. If you don't have them, I would just pause the video and take these notes down. Ask Mr. Clay for this worksheet if you don't have it, or for this notes page if you don't have it. What we're going to be learning, our new information, is on the back of this sheet, and that's operations with complex numbers, and then you'll be doing a Delta Math to review that skill set. So we'll dive into this. Again, if you don't have these notes taken down, pause the video, take those notes down, complete that Delta Math for the classwork on imaginary numbers. Again, it'll say that it's late, but you can still access it. Even though it's red, it'll show me that you finished it. And then come back here and complete this operations with complex numbers notes. So when we are adding, subtracting, multiplying, and dividing with complex numbers, a lot of it's going to be exactly the same as if there was an x variable there. So if we had something that was 3 plus 2x subtract 4 subtract 8i, or 3 plus 2x, x, subtract the expression 4 minus 8x, that's going to give us the same result as if there was an I there. And so this is something that we've done before. We did this at the beginning of the year when we were learning how to combine like terms. So this is nothing new. So I notice that I have subtraction here instead of addition. So I'm going to start with this first expression. I'm just going to rewrite it because there's no coefficient out front that I would need to multiply over. Here I'm subtracting 4, so I'm going to write subtract 4, but I'm also subtracting a negative 8i. And if I subtract a negative 8i, that's the same as adding 8i. So now I have 3 plus 2i, subtract 4 plus 8i. And some of us from the past may have learned to put a negative 1 here and then distribute the negative 1 to both. So it'd be negative 1 times 4, which is negative 4, negative 1 times negative 8i, which would give me that positive 8i. However you want to look at it, whatever you've kind of been conditioned to do from Algebra 1, go ahead and do. That's going to work the best for you. Now we're just combining like terms. So we're going to start by combining our integer coefficients. So that would be the 3 and the negative 4. And then we'll combine the 2i and the positive 8i. So what we'll end up with is 3 plus negative 4, or 3 minus 4, is a negative 1 plus 10i. We're moving down. Let's try that again. So now this time I have addition, and there's nothing out front in either of these spots outside of my parentheses. So I'm just going to go ahead and rewrite these without the parentheses because I don't have multiplication. I have addition in between them, and there's no coefficients out front of my parentheses that I would need to distribute into my parentheses. So I can just leave it as it is. And now I'm going to do the same thing. I'm going to go ahead and I'm going to combine those like terms. I'm going to have my imaginary component, and then I'm going to have my real number terms. And so I have 3 plus 5, which yields 8, negative 4 and a negative 2. I have more negative, I'm adding, and I have 8 subtract 6i. So again, same thing as we did with like terms. For multiplication, it's going to be the same thing that we've been doing with variables. So we've been dealing with like x plus 2 multiplied by x plus 4. Same exact thing. You can use a box, you can use FOIL. We're still just multiplying a binomial, a two-term polynomial, by another binomial. The only change is up here. We see that right now we have the square root of negative 1 for I, and now if I do I squared, it's going to be the square root of negative 1 times the square root of negative 1, which just equals negative 1. And so I'm going to go ahead and set up a box. I have 3 and a 2i. I have negative 7 and I, and now I'm going to multiply. Negative 7 times 3 is a negative 21. Negative 7 multiplied by 2i is a negative 14i. 3 times I is 3i, and then I times 2i would give me 2i squared. And now the big difference here is this piece. I squared is equal to negative 1. And so what I'm going to do is, because I have this is 2 times I squared, that's the same as 2 times negative 1, which would be negative 2. So I'm going to cross off that 2I squared. I'm going to write the opposite. It's just going to be a negative 2, because it's the same as saying 2 multiplied by negative 1, since I squared equals negative 1. And now I'm going to combine my like terms. I have a 3I and a negative 14I, and then I have a negative 21 and a negative 2. So negative 21 and negative 2 gives me negative 23, and negative 14 and a positive 3I gives me a negative 11I. For this next one, I'm going to do the box. I'm going to do FOIL, because some of us prefer FOIL. If you like the box better, you're going to get the same result out. And let me just actually back up real quick. If you had done FOIL in this previous one, you would have gotten the same response. You would have gotten negative 21, and then you would have gotten a negative 14I, a positive 3I, and 2I squared. And you would have done the same exact thing. We would have rewritten this as plus 2 times negative 1, which is a subtract 2. So you'd end up with negative 21 subtract 14I plus 3I subtract 2, and we still would have ended up with the same answer. All right, let's look at FOIL on this last one. We're going to go ahead and do negative 2 times 2, which gives me negative 4. Negative 2 times 2I gives me a negative 4I, positive 4I, and a positive 4I squared. So again, that I squared means 4 times negative 1, which is a negative 4. So I'm going to cancel that out and write negative 4. So now I have negative 4, subtract 4I, plus 4I, subtract 4. These two cancel out. I'm just left with negative 8. All right, last but not least is looking at division. And so with division, we are actually dividing both of these terms by 5. So I'm going to rewrite this as 25 over 5 plus 5I over 5. 25 divided by 5 is 5, plus 5 divided by 5 is I, so we get 5 plus I. It's just distributive property, but with division. That's the only difference. If you have something that looks like that, you can just do that. We have something that looks like this. We've looked at some of these in the previous class. We're just going to go ahead and simplify it down. So I'm going to start by breaking down this negative, the square root of negative 27. That gives me the square root of negative 1 times the square root of 27. All over, I'm looking for the largest perfect square that goes into 98. That's going to be 49. So square root of 49 times the square root of 2. We have I times the square root of 9 times the square root of 3, all over 7 root 2. And the square root of 9 is 3, so I have 3I root 3 all over 7 root 2. Now last year when you had something that looked like this, we did something called rationalizing the denominator, which was when we multiplied by root 2 over root 2 to get rid of this square root of 2 in your denominator. So we're going to do the same thing here. That's going to give me 3I root 6 all over 7 root 4. Since the square root of 4 is 2, we get 3I root 6 all over 14. We're not going to do a ton with this right now, as we're going to spend a lot of time with this as we move forward into our radicals unit in a little bit. Over here, we're going to do the same thing. I need to start by simplifying this negative 27. So I have 27 subtract square root negative 1 times the square root of 9 times the square root of 3. We just did this one up above, all over 18. So we have 27 subtract 3I root 3 all over 18. And now I'm going to break it up. I have 27 over 18, subtract 3i root 3 divided by 18. And we're looking for common factors. So 9 goes into both of these. So this is going to divide by 9. That's going to give me a 2. Divide this guy by 9. That's going to give me a 3. So I have 3 over 2, subtract, and the same thing here. 3 goes into 3 and 3 goes into 18. So this is going to become a 1 and this becomes a 6 because I divided both of those by 3. So I end up with I root 3 all over 6, and this would be my final answer. Last but not least, I'm going to practice that skill from up above. Start off by simplifying both of them. I have the square root of -1 times the square root of 16 all over is the square root of 25 times the square root of 2. That gives me 4i. Since the square root of -1 is I and the square root of 16 is 4, so I have 1 times 4. In my denominator, I'm taking the square root of 25, which is 5 times root 2. Again, if I have a radical in my denominator after I've fully simplified, I'm just multiplying by that radical. Square root 2 over square root 2. It's called multiplying by a smart 1. So I get 4i root 2 over 5 times root 4, which gives me 4i root 2 all over 5 times 2. Now I'm going to take one last look. Notice that 4 and 10 are both on the outside, so I can simplify them further. And they're both divisible by 2 because they're both even numbers. 4 divided by 2 is 2. 10 divided by 2 is 5. And I am all done. 2i root 2 all over 5. All right, so what I'm going to have you do now is really focus in your Delta Math on this section up here, the addition, subtraction, and multiplication. The division, we're going to maybe have 1 or 2 problems, but it's not going to be the primary focus. And I'm not going to do a lot with the rationalizing the denominator until I'm with you guys to kind of debrief on that. All right, I will be able to see the Delta Math as you guys are working on it. So please make sure that you are working on that throughout class. Watch videos if you're stuck on anything. Those help explain. See the C solution to help you work through things. And Mr. Clay is very well versed in this stuff, so feel free to touch base with him if you have any questions. I will see you all on Tuesday.